Hi guys, welcome to the Biomechanics 1 video series. What we're looking at in this specific video is one-dimensional motion. There will be a couple of things that we'll unpack, and this specific sequence of videos regarding one-dimensional motion will be broken into about 4 or 5 smaller sections just to make things a little bit more manageable. One of the very first things that we're going to be looking at deals with concepts around speed, velocity, and acceleration. And in this specific video, we'll be looking at speed as the first point of departure with regards to the equations that govern speed and the various ways in which it typically applies. So speed by definition is equal to some distance traveled, right? So I'm moving from point A to point B, and I'm doing that in a specific time period. So relative to the time that is ultimately elapsed, right? So in a way that I would simplify that is to state that speed is equal to the distance divided by the time. What's really important if I look at each of these components is that distance is always some positive quality, denoted here by it being bigger than 0. It just means that it's always going to be positive. So it takes no account of direction. It's purely a number of some given size. So I've either traveled 5 meters or 10 meters or 20 meters without any specific reference to direction. It's always going to be some positive number. Time as a quantity is also always positive. I can't go backwards in time. It's always forward. I'll also just get a number, so it's 1 second, 3 minutes, 5 hours, whatever the case may be. It's always positive, which therefore implies that speed as a unit will always be some positive value, some given number, right? I've either moved or traveled at 15 kilometers per hour or 5 meters per second or whatever the case may be, but it's just going to be some kind of number. Which brings me to the units. When it comes to all kinds of analyses, the units of measure are going to be really important. So when we look at some value that we are denoting, we'll always put a bracket around it to indicate that we're doing a dimensional analysis, which basically just means I'm looking at the units with which I'm dealing with when I'm analyzing an object. So these brackets just refers to units, right? So I'm just going to put that in brackets. Okay. So in terms of speed, I'm always looking at some kind of length. Again, I'm putting brackets around it, which means I'm doing a dimensional analysis, divided by some unit of time, right? So length in our case is going to be measured in meters, and I'll tell you why in a second. And time is going to be measured in seconds, right? When it comes to various units of measure, we always go by the SI system. It's basically French for the International System of Measures, which dictates that speed is going to be measured in meters per second. Okay, that is the international standard. Unless you're in the States, then you'll go by feet per second, but that's a different matter. We're dealing with the metric system, so it's always going to be meters per second, right? However, speed can also be measured in various other units. The ones that you guys are probably more familiar with is kilometers per hour. In the States, it'll always be miles per hour. When we deal with running and we're trying to prescribe pacing strategies, we'd usually calculate things in meters per minute. And you know, depending on what you're analyzing, I mean, speed can even be recorded in centimeters per year, right? If something's growing very, very slowly or something's moving incredibly slowly, there are various ways in which speed can be measured. But what you'll notice is that each of these, as per our definition of the actual units themselves, it's always going to be some length divided by some measure of time, right? Kilometers is the length, hours is the time, miles is the length, hours is the time, meters is the length, minutes is the time, so on and so forth. Okay, so if you're taking a journey, you might be interested in the average time, right? Might be interested in average time, average speed, right? How fast do you have to travel to get from point A to point B, which means that average speed in and of itself has a definition. So average speed is something that we are interested in, and it means that by definition it is defined as the total distance traveled divided by the total time elapsed. Okay, so I'll just have to explain one other thing. Again, you're seeing something that you might not have seen before, but these triple lines means true by definition. Okay, so I'm going to take you guys to a concept test. So say for example here you were taking a journey in which you are interested in calculating the average speed. So you're going from Port Elizabeth, right, as your starting position. We'll take that as time 0. You're traveling 50 kilometers and it takes you 1 hour to travel those 50 kilometers to Uitenhage, right? You might want to spend some time at a car factory or whatever the case may be, right? You spend a whopping 1 hour there, after which you grow tired of it and you realize you've got a lecture to get to, and you race back to PE that same 50 kilometers in half an hour. So the question then becomes, what is the average speed of the round trip? You've got 5 options: A, 0 kilometers per hour, B, 67 kilometers per hour, C, 40 kilometers per hour, D, 75 kilometers per hour, or E, none of these. So I urge you guys to pause it, try and calculate it, and then once you're done you can just click play again. Okay, I'm assuming you guys have given it a go. The answer that you should have gotten is 40, and we'll look at why that may be the case, right? So if you're looking at average speed, right, which we denoted as being the total distance covered, so well, can't argue with the fact that it took me I traveled 50 kilometers to get there and I traveled 50 kilometers to get back, so that gives me a total of 100 kilometers. The question where most people get stuck is, do I include this hour wait? Well, by the definition of average speed, yes I do, right? It is the total time elapsed for my complete round trip. So I have 1 hour that it took me to get there, I spent an hour there, and it took me half an hour to get back. So I divide this by the 2.5 hours, giving me a final answer of 40 kilometers per hour as being my average speed. And you might ask yourself, well, that's pretty stupid, why must I include that 1 hour? Well, in this case the hour is an exaggeration of a fact that happens on a day-to-day basis, right? If you leave your house in the morning on your way to varsity, you may be interested in how long it takes you to get from where you stay to varsity and the speed at which you'll have to drive to get there on time, right? But you've got to factor in all those robot stops, right? Every single time that a car pushes in front of you and you have to come to a halt, or the fact that you have to quickly go to the shop or put in some petrol, whatever the case may be. If you, interestingly enough, look at the speedometer throughout the trip, you'll realize that you, at some points in time, might be going 80 kilometers per hour, sometimes 60 kilometers per hour. But once all those stops are factored in, most modern cars can actually give you what the average speed was of your trip. And you'll find for movement within the city, most cars tend to average around about 40 kilometers per hour. So that's really important aspect to take into consideration, because like I said, when you're trying to estimate the time of your trip, it's the average speed that will dictate how long it's going to take you to get there, right? And that is factoring all those little stops in between, because you'll know that in the city your average speed is only going to be 40 k's an hour because of all those stops that have to be accounted for. Okay, so it's the same thing that you can apply to numerous other situations. So every single time that you're on a holiday trip or a business trip or whatever the case may be, it ends up being the same kind of a concept. Okay, so that's speed taken care of. The next video clip will focus on velocity and unpacking that a little bit more and showing us the differences between speed and velocity. There's just one thing that I want to finish off with on here, and that is that because speed only takes in a magnitude, it means it's only got a size. We define this as a scalar quantity. So speed is an example of a scalar quantity, and scalar quantities, all scalar quantities, so something such as time, something such as distance, right? They only have numbers associated with it, not direction, right? So we define those as being scalars. Okay, so that's it for now. Thanks for watching, and tune in for the next clip.